Hello everyone and welcome to a new tutorial on Grasshopper. Today I will continue focusing on the TOPO Kit tool that it is available as part of the LangKit plugin for Rhino and Grasshopper. Today I will show you in particular how to create a topographic mesh using data that has been derived from remote sensing imagery like DEMs, digital elevation models, and also from LiDAR point clouds. So to start here, we'll explain basically the two types of data we're going to use. One is the DEM, which stands for digital elevation model, and the other is a LiDAR point cloud, which has millions of points. Obviously, the DEM can be derived from a LiDAR, but sometimes you may find DEM, sometimes you may find available LiDAR, sometimes both. So the process for let's say analyzing the DEM, the DEM basically is just a raster with pixels, and we are gonna derive from this. We're gonna calculate point clouds in order just to use that in the Topo Kit. While from the LiDAR, we're gonna explore two options, and I will explain you this more in detail. So from the LiDAR point clouds, we're gonna go in two directions. The first one is we're gonna generate contours, and these contours will be generating in Cloud Compare using the raster to cloud option. We're going to export them as a shapefile, and then we're going to import it into QGIS. And in QGIS, we're going to export it as a DXF file, AutoCAD DXF. You can also have the contours ready from any other source in DXF or an AutoCAD format. So we will skip this. You don't need to do all this process. But this is for when you get LiDAR point clouds. And the second is generating points. Using these points, we're gonna in Cloud Compare to subsample the points. It means reduce the number of points because we have millions of points. We're going to extract only the ground points because we want to do the terrain only. Subsample, and then after subsampling the points, we're going to export them as SIC or ASCII. It's a ASC format, and the SAC format will be imported into Rhino and Grasshopper, and the same, the DXF will be imported into Rhino and Grasshopper to be used in the TOPO Kit. And the other option is using DEMs, digital elevation models, which are different because these are rasters. And the DEM, the process we're going to follow, it's we're going to convert them into XYZ, and then from XYZ, we will do two things. We're going to save them as an ASC and follow this sort of process. And so we're going to use points here. And then so the other option is from XYZ, we're going to import it in. All of this will happen in Cloud Compare. We're going to import them, and then we're going to create the contours there, and then we're going to export them as a shapefile. We're going to then export it in QGIS, the DXS file, and then again to Rhino and Grasshopper environment. So as you can see here, we have four, let's say, options. Previously, I already explained you how to work on with Topo Kit in the basics. Watch my previous video. There are these basically the processes. We have pipeline geometry with links to layers. And then this in case these layers are contours and spots, as I explained you here, contours and points. And they will be connected to a geoset. And from the geoset, we're going to create a topo mesh. We're going to draw the mesh, and then we're going to visualize that. And then we're going to do some contours analysis, and then finally elevation and slope analysis. So I will disconnect this for now because that will reduce, computational time. I will disconnect this for now, this as well. And I will explain you what I did here. So you can find this script and explanation in a previous video. Um, I created the 4 different methods. The first is using the LiDAR-derived contours. The second is the LiDAR-derived point clouds. Then the other 2 variations with the DM-derived contours and DEM-derived point clouds. So in order to start here, so just for your information, I use Elvis Geoscience Australia. It's a data portal where you can download LiDAR point clouds and as well that DMs. As you can see here, I already selected the grids that I wanted. I put the industry that I belong, environmental, it could be education, your email, and then you can order the dataset. And when the dataset is ready for you, it will be sent to your email, and then you will have it as a zip file. You have to unzip the folder, and then you will have the DM in TIFF or GeoTIFF format. There's something I forgot here. The DM is in GeoTIFF format. Meanwhile, the LiDAR it's in LAS format. Um, as you can see here, the point clouds are in LAS format. So let's start with the first method, in which we need to use the contours derived from the LiDAR. We need to open Cloud Compare. In Cloud Compare, we're going to open the point clouds in LAS format, which are these ones, open. And we're gonna apply the process. I have plenty of information on how to use Cloud Compare, plenty of data and video tutorials in my YouTube channel. So have a look at them if you want to learn more about it. So here they are. We click on our point cloud. We check the number of points. 32 million is a vast number, very large number. And this is because basically this is covering a huge amount of land with trees and vegetation. So we only want the ground points. So we have to do a process of selecting by classification. So we go here. I have a specific video tutorial on this, so I will go quite fast. I'm going to select only the ground points, and then I'm going to extract the values and then put export. So now I have only the points corresponding to the ground. Here is very important to say sometimes there are gaps of information. So there are very different ways you could do to sort it out this problem. But before doing that, we need to check again the number of points. Or 15 million is just too much. So because of that, we need to do a sampling or subsampling process of reducing. So you choose a space, and then we can put 2 meters perhaps to do the first trial and see how it goes. So now we have a 221,000 points, which are more manageable. You can see here there are gaps. So in order to fill those gaps, there are different options. One, and the easiest way is just go to this tool called Convert a Cloud to 2D Raster. Put in a step of 1, choose the height and height grid values and the set direction, and click on the interpolate scalar fields and use either maximum, average, or minimum value. It's using the values of all the point clouds in the surrounding areas or around those gaps and averaging the value, which is what I want. And we choose interpolate. And then we upgrade the grid. So you see here the gaps have been filled. So there are 2 options here. We can export this as a mesh, we can export as a cloud, and we can create a contour plot. So the first thing is let's export this as a cloud because that's what I want. Um, and this is my new cloud. As you can see, the gaps are much better, have been filled. As you see, more gaps. Some of them it's not possible because it's a vertical, let's say, a cliff. It's a vertical surface, so we managed to have a quite good amount of points. As you see, it's 1 million. It's still too many. I recommend you less than 100,000 points if you want to import them into Rhino and Grasshopper. I run a lot of these exercises, and with 200,000 points, just crashes. So before reaching that point, we're gonna now, with this sort of subsample, we're gonna save that, and we're gonna subsample again, sorry, and let's try again, 2 meters. And then we have 250, it's still a little bit too much. I suggest to put here, let's say 3.5 meters to see how it goes. Okay, now we have 64,000 points, that's better. So what we're gonna do with these 365, 17,000, we're gonna save them. We're gonna save them as an ASC file, okay? And we go here to point cloud and we save like ground ASC, and we just need to be sure that the format is ASC, okay? We save, we need to replace this. The coordinate precision is fine to keep it as it is. Check the separator. Separator has to be space, could be semicolon, but if we use a space in Rhino, we'll have to use a space. And then check the other things are unchecked, save, and that's it. So we have here our process data, point clouds, it's 9,000 kilobytes. It's really good compared to 900 kilobytes. Okay, so that's the first step. That's for the points. Now, let's go back to this interpolated point cloud in which we have approximately 1 million points. And let's go back to the raster to cloud or rasterize tool. Let's put up gray. And now we go to the contour plot. So I'm going to generate contours, and these are the contours I'm going to use in Rhino and Grasshopper. So the start values should be 0. Our step is the distance in between break lines or contours. In this case, I want 5 meters, not to be I don't want too many contour lines. And as you can see, if I put generate with these values, the vertex now count indicates the number of vertex and the granularity of these sort of lines. And you will start adding a lot of, let's say, detail to the contour line, and it's too much. If you reduce this to 200, I found that it generates a much better and cleaner set of contours. So once we have done this, we put export. And as you can see now, all have been exported as an individual lines, all with elevation. That's great because that is the information we need to create our topography in Rhino and Grasshopper. So what we're going to do is, you see, I can select one by one. What we do is we select the whole folder and we put save. And then it's time to put contour 5 meters in shapefile format. Remember our process, contours to shapefile. We save. And here we need to choose set as the vertical dimension and then uncheck the other options. And that's it. Now we can go to QGIS, open our folder, home folder. Let's go there. Let me see if I can find the data sets. We're in, I made a mistake, he's here. Land kit, data sets, and process, point clouds, and DEMs. So here you will find your shapefile, contours, beautiful. They don't have a coordinate. You don't need it because anyway, Rhino doesn't work with coordinates, but if you are feeling better, you can add just the coordinate reference systems to avoid any issues. As you can see, disappear. You need to zoom to layer, and then the layer has a awkward, let's say, projection. It's because here at the bottom, the reference system doesn't match, so we need to match both reference systems, and then it's perfect. Once you have selected this layer, you need to export as a feature called AutoCAD TXF, and select the name. So we're gonna select contour 5 meters dot DXF, and we're gonna save. Now the projection is there. Keep the rest as it is except the geometry. We need to choose line string and include the set dimension. Once this is done, untick this and we put OK. So this will take a while to process. Okay, so we have done the first step. We have already the point clouds in an ASC format. So we have all the data that is ready for the first two options for Rhino and Grasshopper. So back here to Rhino, we have here the layers. So the layers we're going to use contours and spots for the LiDAR data and the contours DEM and spots DEM for the DEM data. So these are the 4 layers, the 4 different methods. Okay. And then we're going to use we will use this geometry pipeline to collect all these sort of contours and spots and bring them into the model, as I explained before. So the process has been completed. We're ready to go. And then let's choose the contours. Just need to be sure that the names match perfectly. So let's select this as a current layer. And then in the perspective, let's be sure before proceeding, go to tools, go to options, just to be sure what are the units of our layout. And so everything is in meters, it's all good. If not, you need to be sure that they are in meters or in any of the dimensions you use where you work. Now we put file import, and we need to choose the DXF because that it is the first format. DXF, and go to point clouds and this contour 5 meters. Open. Keep everything unchecked except the last one here, which is import and reference line types. And just be sure that everything is in meters and set the layer layout to the color. That's all. And so it should be imported. If by any chance you lose your data like this, so you just have to click on the command line, click zoom, all extents, and your data, sorry, your data should be, or should be there. Look, if you select it, so you can click zoom to select it and the data will appear there. What happened in this data has been imported into an independent layer. So you have to select all the lines, right click on the contours and put change object layer. So now it's moved to that layer and give a color to each layer. Let's say red, orange, light blue, green, just to be able to identify. So let's just see here is in the red one. Let's save this. Great, we have the contours. Now the only thing we have to do is connect the contours to the geo set. And then the geo set is already connected to the create topo and draw topo tools from the TOPO Kit. So it will take a little bit and will be done soon. That's it. So you don't see anything, of course, because we have the preview has been disabled. So let's turn off this just to make it simple. And you will see here, we'll connect the mesh to this mesh and we're gonna turn on the preview. Here it is our mesh. And you see here a lot of, let's say, granularity or imperfections. And that it is because if I turn on my points, you see the points where all along a line. So what is happening here basically is the method of interpolation along this line is just to try to generate a triangular irregular network or TIN joining points from two different heights or elevations. So you have a lot of points in this line, a lot of points here, nothing in between. So there is a linear interpolation. So what happened is the larger it is your distance between lines or your contours, the coarser and more triangles you will see, so the less resolution you will have in your topography. The closer these lines are, obviously more computational time required, but then a smoother terrain, right? So this is the first method. That's our geometry. You can create a custom preview and see the geometry, and you can bake the geometry and export the points. So if you want to simplify this, you can bake this mesh, send it to the default, and then visualize it in render. Where it is render? Here. Obviously the material is there. Yep. So that it is your first mesh. Good. Wireframe. So that it is the first, let's say, method. Now you can create contours generate new contours from this mesh. So we just grab this shape. So new contours will be then generated. And again, it's based on the data that is being filled between the gaps. Looks pretty good for just being a very generic, simple model, correct? We disable this and we disable the custom preview and this mesh. So now we go for the second method. The second method uses the LiDAR point clouds directly. This is more time consuming than the other one because the number of points is much, much larger. That's why try not to go for a very large number of points. We were around in the subsample, there were no more than 65,000. So before proceeding, save everything. And now we select the current sorry, we turn on this, turn off this, and we select spots as the current layer. And we click again on import. And we choose now ASC. And this is the ASC we created. And we say open. And then here is important, as I said before, if we method when we exported was a space, the delimiter, we need to use a space. Okay, and there are many people create point clouds as a huge a whole entity, so all points are imported as a whole entity. In this case, we want individual points because we're going to use those spots as elevation values for our topo mesh. So we just check that option, we uncheck that option, and we keep it like this. So we just click OK, and this will be imported. So now it's done. You will see they are in the correct spot. Look at the distances. If you compare this with the initial points here, let me turn on the preview. You will see the difference. There are more points along the lines, but there are many more points in the spaces in between these lines. So what will happen is when you have points, you will have different points and the mesh will be created based on those points. So it will be the larger the number of the points, the smoother the surface, the smaller the number, the more, let's say, the coarser would be the surface. So we're gonna disable this. Now they are in the spots. This also pipeline has already, let's say, absorbed or process those points. We have already how many points? There a lot of points. And then we just need to connect this to the spots and it starts the processing. This will take a couple of minutes because there are many more points to be processed. It's done. So we turn off this layer and we connect here to turn on the mesh. As you see here, the mesh is slightly different. it's more granular. Let's turn on the geometry preview here, the custom geometry preview, and then let's do the same with the other one. As you can see here, the difference. So all this gap, all this difference in color, it's because let's change this to an orange. Now, as you see here, there are a lot of information that was lost because they were just assuming there is a linear interpolation between the points along this contour and the other one. While here you have a lot of extra points being calculated in between with each of these points with a specific altitude or sorry, elevation. So that's the difference, more precision, but more time consuming process or computational exhaustive. But then we just can assess our or evaluate our meshes as before with the topo mesh elevation. Let me turn off all of these. As you see here, this is one of the elevations from the contours, and this is the one derived from the point clouds. Not difference, but just smoother in some ways. And again, you can disconnect this, and then we can assess the slope. There we have the slope is much more dramatic. Obviously, the slopes close to the cliffs are more vertical. And you see the slope reduces towards the top. Okay, this is a very good example. And then we're going to change this more triangular, the shapes, because obviously it's generating meshes from groups of slopes. And then if we connect here, this one instead, you will get a completely different result. The triangular regular networks are much finer. So that's why you get a much more smoother. The more points, the smoother it is. But it looks quite good. And for the analysis of which slopes are, let's say, steep and which ones will, for example, require more vegetation, or this should be the darker colors should be vegetated in order to reduce, for example, soil erosion. So this is a very practical tool for designers to make decisions on landscape architecture, landscape architect designers. Okay, so we have done these two first methods. Now, what happens if we don't get LiDAR and we just only have DEM available? So as I said, the process for the DEM is just to save them or export them as an XYZ, and then do the whole process again in Cloud Compare. So that's what we're going to do now. So let's imagine we don't have any of these things. We go to QGIS, we remove this as well. And then we have only the GeoTIFF, as you see here, projected. This GeoTIFF has 1 meter resolution, which is quite fine grained, okay? It has elevation information in each pixel. What we're gonna do is we're gonna go to the raster menu and go to conversion and translate into a different format. And the format, we can choose here the projection. And the most important is to choose the format at the bottom, convert it to, we choose XYZ. We go to DM data projected, and then we put contour. Let's put points, DEM points, DEM points dot XYZ. Okay, and we save that and we run it. So it's pretty quick. Now we go to Cloud Compare, and then let's open that file. Is XYZ. Let's find for that format here. DM points XYZ, and this is the translation process. Apply all. last input, just do all, and then we got. So now let's check how many points. We have 1 million points. This is good if we want to derive the contours. So let's do that first, and then we can proceed with the rest. Let's go here. We just put, as we did before, set average, average value, upgrade. We can choose to resample the input cloud, but we don't want to modify that one. And there we go to contour plot, 5 meters again, the start value 0, and our vertex 200, and we put generate. And you see here the contours are slightly smoother compared to the previous time. Then we put export, and then we got them all here. So we choose the whole folder as before, and we put save, and we're gonna call them contour 5 meter DEM, and we're gonna call them DEM just to be able to identify these were derived from the DEM, and it's again a shapefile contour, and we save it. We save with a set value in vertical, and that's it. And now we got these point clouds, we have 1 million, and we need to subsample them. We subsample then space again. Let's try with 3.5 again and see how it goes. So this subsample is now 80,000 points. Should be okay. We can save, and again we are going to save these DEM points as ASC. The separator is a space, the rest is all good, and we save it. So we have already the data ready to go for the last two methods. And we just repeat exactly what we did before. We save our information. We go to the next layer. We choose the current layer contours DEM, and then we just click import. And we will import the contours. We haven't done one step. In QGIS, we need to grab this, refresh, this contour 5 meters DEM that they are here. You can check they have an elevation using the QGIS 23GS tool and see they have an elevation, right? So once there, we save, we export this and save this feature again as a DEM, a contour DXF. Just use again the DEM at the end just to identify these were derived from a different type of data set, and say DXF, and we choose line string. We include the Z dimension, and we save it. And meanwhile this is saved, we can come here and start importing our spots rather than our contours, just to save some time, because these take a while. So let's choose this as a current. It's on. Just let's be sure that these two, yeah, they are on. They are on. And let's put import again, and we will import points. So it's DEM points in ASC file. Okay, space again, and we just import individual points, and we click OK. It would take a little bit because there are 80,000 points. There we have our points. Yes, there are all the points, as you can see. There are all the points there. You see that they are more linearly organized because of the process that we have followed from the DEM. The DEM is usually pixel by pixel calculation, so that's why you see they are more like a linearly or regularly spaced. Now, we just follow the same steps. We just save everything before continuing to avoid when crashing to lose data. And so here, these are in the spot DEM. They're already processed by this tool. As you see, we have 80,000 here, this match, and we just click on spots, and this will process again for a couple of minutes. Processing has finished, and we just connect to the mesh. So now we can turn off the layer when the process has finished. And you will see there your beautiful mesh again. Now you want to compare this mesh with the previous mesh. Let's change the color here to, yeah, purple. And let's turn on this. As you can see here, there are slight differences, obviously. You can run different calculations to estimate the difference, but it's generally similar, but it's just because the methods are completely different, okay? You can turn off this preview and instead turn on this and then grab again our contours here and see it also the differences in the contours. So these contours, notice the lines are slightly, let's say, abrupt. But you have here again contours. You can customize the preview visualization of these contours if you want. Okay. Now the last but not the least method, we're just gonna do the customized preview here. We select the current layer, the contours, the EM, and again we import. And now we go to the EM and we select the XF. It should be somewhere here. AutoCAD DXF, yep, 5 meters DEM. We follow the same steps and we notice that it's here meters and meters and all good. They are there. As usual, they are in a different layer. We need to select them all. Go to the contours DEM and change the layer. We can delete this. And now they have been already processed here. What you need to do is just to connect this to the geoset. And wait a couple of seconds, it should be done soon. Done. Now we turn off this layer and we connect to our mesh. We turn on our custom preview. There you are. There you have here the same process, the same method, but you see again how rough it is compared to this method. So there are two ways here you can do. And then we can run the analysis again as before. Sure. Yep. So what we could do is remove this and obviously where is the mesh here? We can run the contours and compare the contours again. Very different in some parts, in other ones not too much. And we can run the analysis as before. Let's do the slope so you can, that's the most evident. The elevation doesn't change too much because the elevation is pretty much the same. Let's try to find this sort of vertical view and compare this sort of view, analysis, which is very coarse, and the triangular irregular networks are very coarse versus this one. Then you get a much better resolution and then better analysis of the slope. You can rotate the model and then you can bake this model if you want. Obviously, it was not going to bake with the colors, presumably. Let's see. Yeah, well, it's not rendering the way it rendered all the meshes because they come from the analysis. So there were a lot of meshes groups. we're gonna put Control Z. That's it. We don't want so many messages in the default. Sorry. Where they are baked then. This is very weird. Okay. Something is here. It's all good, but yeah, for some reason it was there. Yep, that's it. So here you got very powerful tool and method in order to import LiDAR derived point clouds and contours and use them to generate your topographic terrain. So this will call it this session creating topographies from LiDAR and DEM. So you can see these four, let's say, methods or different type of processes reach to particularly very different outcomes, but that will depend on what you want this for. This is 1 kilometer by 1 kilometer. So if it is very large scale and your analysis is more at territorial level, you can, let's say, compromise a little bit on resolution and then speed up the computational process by reducing this resolution and then because you're covering a larger area. But if you're focusing just on a very specific part of the design, then it will be more difficult and then will require more detail. Then you increase the resolution, the number of points. So but these three tools work together: QGIS, Cloud Compare, and Rhino and Grasshopper. It's really important you manage to make them talk to each other. And that's what we have tried today in the tutorial. I hope you find this very useful. In future, we're gonna focus on how to create curbs and walls, and then later how to create paths and stairs, and then use these features to modify your terrain so the terrain adjusts to these features. So see you in the next video, and I hope you find this really useful. Take care. See you then. Bye bye.